Okay, so how did our sun come into being, and how did our solar system come around as well and come into being, and our galaxy? We're going to start thinking about that, and in next week's work, we're going to have a look at the life cycle of stars, which is really cool. But right now, I just want to introduce you to just the birth of stars. So that's when stars start out. If you think about all those big like nebulae. So do you remember that term, which means clouds? Like you've got a whole lot of gas and dust floating around. And remember, there was that first generation of stars, and they were very bright, but they didn't live very long, and they exploded in supernovae, which we'll talk about soon in more detail as well. But you should by now at least know that means it's just a big star that basically sheds its outer layers. Yeah. So basically, what's happened is there's a whole lot of gas and dust, and it's close enough that eventually, over millions and billions of years, the particles actually come together, and they're pulled together by gravity. And as they pull together closer and closer, the gravitational attraction gets higher and higher, just because there's more mass in a smaller space. And what then happens is it starts spinning. And as it starts spinning, the most stable form for that to end up in is like a ball, and you get what we call an accretionary disk around the edge. So you can see in this picture below here that there's this like flat, like pancake section, and if you think about like that's a whole lot of dust and gas there around like a central section. So basically, what's going to happen there is you're going to have a star forming in the center, but not all the material is going to make the star. Some of it is going to just coalesce in chunks, and form planets and form moons to those planets. And as you would expect, like the heavier, like the more dense stuff is going to end up closer to the star, and the less dense stuff is going to end up further away from the star. So that's why if you think about our solar system, we have those inner terrestrial rocky planets because they're made from the more dense materials, and then we have the lower density. They're bigger, but they're lower density, and they're made of gas and ice and things. The big the giant planets at the further out in the solar system. So basically, you get this big chunk of gas and dust. It starts spinning. In the center, everything's getting pushed together further and further and harder, and it's getting hotter because of that pressure. And eventually, when you get enough heat generated in there, and you actually get those hydrogen atoms forming that plasma ball, you will actually get nuclear fusion happening, and that's when we get the birth of what we call a main sequence star. So our sun is a main sequence star. It just means, think of it as middle-aged at the moment. That's like the best way to think about it. So basically, main sequence stars they can just live like that for anything from millions to tens of billions of years, depending on their size. So the bigger they are, the brighter they burn, the quicker they die. So our sun's fine. It's like a nice kind of like just average size star. It's got quite a good lifespan, but the bigger ones actually, they last much less time than the smaller ones. So basically, all of the stars though, there's more than two, but we talk about there being two kind of nuclear fusion chains that power them, and one is predominant in smaller stars and one is predominant in larger stars. Now, fusion will only happen at really high temperatures, because basically, like I said, you need to have that protostar collapse and have those huge pressures build up, because if you don't have that, if you think about if you've got two protons, they're both positively charged, there's going to be a really strong repulsive electrostatic force between them. You're not going to get them smashing together. So you need to have really incredibly high temperatures for those fusion reactions to occur. And that only happens once that protostar has collapsed down to become a main sequence star.